Hello everyone, today we're going to talk about moments, beams, reaction, and the UDL. But like mainly we're going to talk about like these stuff, like this thingy majig. This was the main topic what I want to revise. So basically first we're going to talk about the rigid body thingy. So a rigid body is where particles within the body cannot move relative to each other. So basically it's the same. Also with equilibrium, the forces so basically I think we talked about this before. So logic, blah blah blah. So when it's equilibrium, it means it doesn't move. That means all the forces in x direction, which is this horizontal, must equal to 0. Same with the or y, which is vertical, up and down, 0. And then moment of z. Z is what is z? It's basically when it's like, what is it? Basically, I can't even remember. It's like basically, it's just another force. Yeah, like these are to combine or whatever. The main point, everything has to be equal to 0 when it's an equilibrium. To explain the rigid body diagram better, as an example, I can say that let's say we have like a pole, right? It should be straight, and basically the area here, like the pole and this red thing, it's O, right? And we have a force and another force acting upon it. So this is a moment. So this would basically a moment when it gets deformed, technically. Basically this would create a moment, like it would move it, right? It acts horizontally on it, so it doesn't create a moment. It just like, you know, like compresses it. And basically this is different. This would make it move. This might like make it like smaller, but no. Let's say if this wasn't rigid. So basically, if the case was that because of the force, it would bend. In that case, the other force would make it also go down. So that case, that would also be a moment. However, these are very complicated, so we're not going to talk about them. Yeah. What else? There are 3D scenarios. The ones that I just showed were the 2D. I don't know how to explain. Basically, these are only the 3D scenarios. In the 3D, there are three more, which we're not going to talk about because, yeah, no thank you. And the conditions allow, like the equilibrium conditions allow us to solve for support reactions, forces later on, and internal forces in thrusters and beams. So basically, the number of equations is the amount of unknown you can solve. So this is how much stuff we can solve. We can solve the x, we can solve the y, we can solve the z. So yeah. So basically, there are many support conditions in like the whole blah 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 situation. Basically, the first one, pins, the most basic ones. So you have the stick. Oh my god. Basically, the pole, blah blah. This is the pin, right? And what I mean by conditions is like the forces the thingies have. For example, the pin, it has the forces going vertical and horizontal. So it has the y and it has the x. So this is how it works. This is how the pin works. So it goes both ways. Then after we have the rollers. The rollers basically they can be as a circle, or they can be most of the time like how I saw them is like this, and basically the rollers, they only apply upwards. However, there's a situation like basically it can also be like this. Let me show you. I'm not sure how do I draw. Okay, basically it can also be like this, and so the force will go like this. So I'm pretty sure, so wait, this vertical and this is horizontal, I assume. No. Oh yes. To be fair, I don't even know, but basically this is how it is. Fixed. Fixed is basically logically it's fixed. So the thing, and I don't know which one. Oh, I think this is it. So basically the pole and the stick, the forces this one has is that it goes upwards, it goes like this also, but also has a moment that goes like this. How it works, I don't know how the moment works. I assume it's because like it can fall like this, but then I guess the moment would be like this. So I'm trying to figure out how, but I don't know. So I'm not even gonna, oops. And an example of how all the stuff works is basically the pole. Then let's say we have a pin and the zero thingy. And there's a force acting like here. 1, 2. How would we solve this initially is that I like basically draw the forces like this. This is how it looks, right? Yeah.